Okay, so hello everyone. Today we are studying structure and bonding, which is the first unit of organic chemistry that we're going to delve deep into. Okay, so we have here the worksheet, fill in the blanks, and we're going to go through it together. And I'm going to leave in the answers in the worksheet, hopefully at the end of the video. Okay, so first of all, organic chemistry is the study of carbon. Carbon compounds containing what? So most of the time, the carbon compounds is, the carbon has 4 bonds. And most of the time, we're going to study it bonded to hydrogen. Now, of course, it can bond to oxygen, sulfur, and multiple things, oxygen, nitrogen, all of these. But we can say organic chemistry is the study of carbon. Now, we're going to talk about atomic structures and bonding. So atoms are composed of 3 subatomic particles. So this is just review from general chemistry. So we know it's composed of protons, electrons, and neutrons. Alright, so this is just the basics we know. We know that the protons and neutrons are located in the nucleus of the atom, while the electrons are found in the electron cloud. So we can say the protons and neutrons. Okay, say protons and neutrons are located in the nucleus of the atom, while the electrons are located found in the electron cloud, which is, if you remember, let's say we have the carbon, it has 4 bonds right over here, so this forms the electron cloud. The electron cloud is where you have the electrons found. All right, next we're going to say the what charge of an atom is balanced by the what charge, making the atoms electrically neutral, right? So we're going to say the positive charge that is coming from the protons is balanced by the negative charge that is coming from the electrons, which makes the atom electrically neutral. Now we're talking about the neutral atoms. However, you can have ions, which are atoms that are either positive, which makes a cation, or negative, which makes an anion. All right, and then we can say, and what bond occurs when 2 atoms share pairs of electrons, right? So 2 atoms, a covalence. So when a covalent bond occurs when 2 atoms share 2 pairs of electrons. All right, so this is just the review that we have from general chemistry. Now let's move on. Well, let's talk about Lewis structures. So Lewis structures are another big topic, but in organic chemistry, right? So Lewis structures. A Lewis structure is a representation of a molecule showing how what? All right. So a Lewis structure showing how the atoms. It's showing how the atoms are arranged and the electrons are shared. So that's a Lewis structure, right? So let's see, what is the Lewis structure of nitrogen? Right, so since the nitrogen, 1, 2, 3, 4, 5. So it has 4 electrons. It's showing the electrons in the atoms. Now, sometimes you can show the covalent bond with the Lewis structure. For example, CO2. So you could have this as the CO2. You can see the electrons of the oxygens, and you can see that over here. Next, we can say over here that in a Lewis structure, the whats are represented by what, right? So we can say that the valence electrons are represented by dots, right? So you can see here represented by dots. Another thing is blank atoms do not always follow the octet rule in Lewis structures, right? So what are these types of atoms? So this might be a question. So these are called transitional. These are called transitional. All right. So transitional or transition atoms. Let's say transition. Right? So transition atoms do not always follow the octet rule. For example, we have an example. Yes, BF3. So the boron would not have a full octet. If you draw the Lewis structure, it's going to look something like this. All right, the fluorine is so electronegative, it's not going to give the boron. So here, the boron has 1, 2, 3, 4, 5, 6. So the boron has 6 pairs of electron. It's not 8. That's not following the octet rule. Okay. Now let's delve deeper into organic chemistry. Now the first thing you're going to notice about organic chemistry is the functional groups, which is a very important thing in organic chemistry. Right? Oh, sorry, we forgot a question. So here it says, true or false? In Lewis structure, the least electronegative atom is usually the central atom. Well, this is absolutely false. Oh, sorry, this atom. This is true. Why is that true? Because it's the least electronegative atom. All right, the most electronegative atom is going to be on the periphery, and that's an example that I just gave right over here. So here we can see that the most electronegative is away, and the least electronegative is in the center. Okay, don't make the same mistake that I made right now, which is the least electronegative atom is the one that's the middle. So we can say that the carbon is usually in the middle. We can see sometimes sulfur is in the middle. We can see phosphorus sometimes in the middle. We can see boron sometimes in the middle. So, and then we can see more electronegative, and we know that electronegativity increases as you go to the right of the periodic table towards fluorine or up to the periodic table towards fluorine. So that creates this shape right over here. And if you can see the periodic table, and that makes it like that. Right? Now, let's talk about a functional groups. So we can see a what group is a specific arrangement of atoms that gives a compound its characteristics, right? So that's a functional group. Functional group. So functional group is a specific arrangement of atoms that gives the compound its characteristics, and that's what we usually manipulate in organic chemistry. So we have a functional group, we usually change one form of functional group to another form to have certain characteristics and certain properties that we cannot have in other forms, right? So its characteristics and what? Properties. So we can say its chemical characteristics and its reactive. So it's chemical characteristics and its reactive properties that we can have. And what are some of the examples of functional groups where there's a lot? Well, there's one, the hydroxyl. So hydroxyl makes alcohol, which is the OH, right? There's the carbonyl, and there's the amine. Of course, there's a lot more, like the amide, for example. You have the alkene, alkyne, alkane. We can also see throughout organic chemistry, and there's a good table that you can find online that summarizes all the functional groups and the priorities that we can have. So we have the carboxylic acids have the highest priorities, and the halides having the lowest priorities. So when you come naming the atoms or the compound that you have, you can name it using the properties and using the filling in the functional groups. Next, we're going to talk about isomerism. All right, so that's also a very important topic. So isomers are compounds that have the same what? So they have the same molecular formula. They have the same molecular formula, but different structural formula. For example, you could have two compounds that have this formula, C2H6, right? You can have this formula, two of them, but the structure or the way that they are manipulated is different. For example, you could have like different structures, right? Not so much in this example, but you get the idea. Like for example, if you have something like C4H10, right? So now you could have different structures, have the same molecular formula, a different structural formula. That means that they look different, but they have the same formula overall. All right. Next, we can say what isomerism occurs when two or more compounds have the same molecular formula, but different what arrangement, right? What we can say different connectivity, connectivity arrangement, and what is that called? This is called structural. Structural isomerism occurs when two or more compounds have the same molecular formula but different connectivity arrangements. right? So we have the same structural formula, they look the same, but the comp or the atoms, you have something like dashed and something that is wedged. On the other side, you could have the something that was a dash, now it's a wedge. That was a wedge, now is a dash. And something that was a dash now becomes a wedge, right? So this would convert everything back. So this can result in structural isomerism. See, there's the last type, which is stereoisomerism, right? So this is called stereoisomerism, which is isomerism that occurs when two or more compounds have the same molecular formula. Notice that we said here that we have the same molecular formula that also follows through in the other definitions, right? So we have the same molecular formula. Here we have the same molecular formula, but different what? Well, we have the different spatial arrangements. We have different spatial arrangements. All right. Now we have here true or false question. So true or false, isomerism have identical physical and chemical properties. What do you think? Well, the answer here is false. They don't have the same physical and chemical properties. Why? They might have the same molecular formula, but we said over here that they are different, right? So we have different connectivity, you have different spatial arrangements, right? So there's things that are different. They're not identical, which creates different physical and chemical properties. All right, section 6, we're going to talk about bonding in organic compounds, right? So carbon, so here you can say carbon forms how many bonds? Well, we know carbon makes 4 bonds with other atoms, right? So you can have like different examples. I'm just going to say hydrogen, oxygen, and nitrogen. Okay. Okay. Carbon-carbon bonds can be what? Well, carbon-carbon bonds can be either single, so you can see like a carbon bond to carbon, or can be double. So you can see a carbon double bond to carbon, right? So you can see single can be double. True or false question? True or false? Organic compounds primarily consist of non-polar covalent bond. Well, we're going to say organic compounds, okay, primarily consist of non-polar covalent bond. What are non-polar? Non-polar means that we don't have a lot of electronegativity difference between two atoms. For example, Fc, that's a polar bond. But if we say FH, SCH, that's not a polar bond. Why? Because C and H have similar electronegativities, while the F fluorine and the carbon have a high difference in their electronegativity. Here we're saying organic compounds primarily consist of nonpolar covalent bonds, and that is most parts that's true. Why? Because if you remember at the beginning, we said that organic chemistry is concerned with carbons. And most of the time, we have carbons and hydrogens, right? So carbons and hydrogens, they have non-polar, so most of the time, we're going to have a non-polar covalent bond, which makes this statement true. Next, hybridization. Okay, so that's another important topic that we can see. So hybridization is the mixing of what? So hybridization is the mixing of atomic orbitals to form what? Hybrids. So we're forming hybrids. So we have like an s orbital, we have a p orbital from general chemistry, and we're mixing them to form, for example, an sp3 hybridized carbon, right? So carbon atoms in organic compounds often undergo sp3. How do you know? For example, let's say I C bonded to an H, and H, and H, and H. An easy way to know, we can say, okay, so this is an s orbital. This is going to go in the p orbital, this is going to go in the p orbital, this is going to go in the p orbital. Because the C have 4 bonds, that's going to make an sp3 hybridized carbon, right? All right. Okay. Next, true or false question. So true or false, hybridization affects the geometry of a molecule. Well, that is 100% true. And that's an example that I gave you right here. So if you have 4 bonds, that's going to be an sp3 hybridization. If you have something like this, C double bond O, let's say, HH, That's not going to be an sp3, that's going to be an sp2 hybridized. Why? Because that's going to go to s orbital, that's going to go to p orbital, that's going to go in p orbital, that's two p's and one s, so that's going to be an sp2, right? Okay, intermolecular forces, another important topic. All these topics are kind of the introduction of organic chemistry that we're going to see today. Okay, so intermolecular forces are forces of attractions between what? So they're between molecules, right? So we can say they're between molecules, and just right over here. So it's written right over here. So it could be hydrogen bonding, London dispersion bonding, and all these things. So forces are the weakest intermolecular force. So what is this going to be? That's going to be the London dispersion. So the London dispersion forces are the forces that are the weakest intermolecular forces, right? And what are the strongest intermolecular forces? These are going to go with the hydrogen bonding. Hydrogen bonding. Now, of course, there's the stronger one, but we're talking about mostly covalent bonds, but there's the ionic. The ionic bonds are strong, so ion-ion. These are strong. So when we talk about intermolecular, we're talking about molecules. When we talk about intra is between atoms, right? Between atoms of the same molecule. We talk about inter, that's between the molecules, different molecules. Okay, true or false question. True or false, intermolecular forces affect the physical properties of organic compounds, right? So is that a true or false statement? Well, that's a absolutely true statement, right? So of course, if you have the hydrogen bonding, it's going to increase the boiling point, melting point, all right? And that's what it is going to do. Okay, next, resonance. Let's find the blank. So resonance occurs when a molecular ion can be represented by two or more what? Structures, right? So two or more resonance structures, right? So we have a resonance structure, so we have the same molecule, but for example, sometimes you have a double bond, sometimes you have a triple bond that creates a hybrid in some places, right? So resonance structures differs only in the placement of electrons, not the arrangement, right? Not the arrangement of the atoms. Okay, so resonance structures are represented using what? Represented using curved arrows. Okay, so let's fill in the blanks in over here. So these are more of the questions that you can solve. So I'm going to leave them right over here. Try them your own, pause the video, and then we can start after that. Okay, so I hope you had some time doing them. So let's go over them. Okay, so the first one is what compounds contain carbon atoms bonded to hydrogen atoms? Well, these are called, oh, let me try a different color here. So these are called hydrocarbons, right? 17. A what bond occurs when two atoms share one pair of electrons? So one pair of electrons, so one from here, so that's a single bond. All right, 18. The what rule states that atoms tend to gain, lose, or share electrons to achieve a full outer electron shell? Well, that's the octet rule. Octet means 8, so that's the 8 to achieve a full octet. All right. 19. We have what in a Lewis structure? The what? Electrons are represented by dots. We know that's the valence. Electrons. And 20. What isomerism occurs when two or more compounds have the same molecular formula but different spatial arrangement? Remember, that's the third one that we had above. So that's called the stereoisomerism. Let me write that better. It's called stereoisomerism. Okay, I hope this video was helpful. And yeah, so take a look at this, and hopefully that was help you to get started as an introduction for organic chemistry. Have a good one.